Hello guys, I am Ranjan Mishra, Revolution Physics Ghaziabad. Today we are going to derive lens maker formula and lens formula. That is the topic included in refraction by lenses. This formula is very important for both point of view. In term to examination, either there will be a numerical on it or derivation on it or both. Okay, so this topic is very important. Okay, let's derive the lens formula and lens maker formula. Okay, I have taken a lens. Let's have a lens. It is a convex lens. Here, this lens is made of two surfaces. One surface is this and another surface is this. Let A, B, C, D. One surface is ABC and another surface is ABC. There is two surfaces, and for diffraction from a spherical surface, we have already derived a formula mu2 upon V minus mu1 upon U equal to mu2 minus mu1 upon R. Mu is a refractive index in which image is formed. Mu1 is refractive index in which object is placed, and R is radius of curvature of the spherical surface. Here there is two spherical surface. Let the R1 be the radius of curvature of ABC and R2 be the radius of curvature of ADC. Okay. Now let us consider object is here and the medium of object is mu m. I have written m because it is refractive index of medium, and refractive index of lens is, let us consider it is mu l. Okay. Now, if a light fall on it, first it will be refracted from A, B, C, the first surface. Let it make, if there is no second surface, then it must make an image. Let it be I1. Okay. Remember that this image is not formed in this medium. It is in the lens, because the final image will be like this after the refraction from the second surface. It will be the final image. The key point you have to remember in this derivation that I1 is not in the mu m medium. It is in mu l medium. It is within the lens. Okay, this is the key point. If you get this point, there is no problem in deriving the formula. Okay, let it is O, this is I, and this is I1. Okay, this distance is U, and this distance is V, and this distance is V1. Okay, now let me explain. OB is approximately equal to OD because we are considering lens is thin. It is a thin lens. Okay. DI can be treated as BI. Okay, and that will be equal to V. This will be equal to minus U, and DI1 approximately equal to BI1, and that is equal to V1. We have taken the values. Now, first refraction from the first surface, refraction from the surface ABC. Then where is the image by the surface ABC? It is in medium mu L, and this is V1. So we will write mu L upon the image is V1, it is V1 minus object distance. Object is OB, that is it is in mu M, and that is U. I have written OB or OD, that is equal to U. Okay, and that will equal to mu2 minus mu1, that is mu L minus mu N upon R1, because the radius of curvature of surface ABC is R1. Let's say this equation number 1. Now refraction from second surface, refraction from surface ADC. Now the final image in medium mu M. Here this medium and this medium is same. We take medium in which image is formed. So final image is formed in mu M, and it is V. This is V di, that is V minus mu L, because object, this image I1 act as an object for surface ADC, and it is in medium mu L, and its distance is V1, and so now mu M minus mu L upon R2, let it be 2, equation number 2. Now add equation 1 and equation 2. See here is mu L upon V1, and here is minus mu L upon V1. Cancel out. Here is mu1 upon V and mu1 upon U. So result will be mu M upon V minus mu M upon U. Okay. In right side, mu L minus mu N, and here is mu M minus mu L. Here is mu L, here is mu M. If I take mu L as common, it becomes negative, and I can take mu L minus mu M as common, and it will be 1 upon R1 minus 1 upon R2. Now mu L is common here, mu M, and it will be 1 upon V minus 1 upon U, and that is equal to mu L mu M 1 upon R1 minus 1 upon R2. Now if I divide this mu M in this side, what we will get? It will be 1 upon V minus 1 upon U equal to mu L upon mu M minus 1, and multiply by 1 upon R1 upon 1 upon R2. This is first equation. This is equation number 3. Let's say equation number 3. Okay. Now, if I take this object at infinity, if I take U at infinity, then final image will be formed as focus. So this equation becomes 1 upon F equal to mu L upon mu M minus 1, and 1 upon R1 minus 1 upon R2. This equation is known as Lensmaker formula. This is Lensmaker's formula. Okay, this is called Lensmaker formula, and name it as equation number 4. Now from equation 3 and equation 4, right hand side is equal. So from equation 3 and 4, we can say that right side is equal, so left side will be equal, and it comes 1 upon F equal to 1 upon B minus 1 upon U. This is called Lens formula. Okay, this is called Lens formula, and this is the whole derivation. You can take a screenshot. total derivation of Lensmaker formula and lens formula. Okay, thank you. Some numericals on Lensmaker formula and lens formula. Here is the question: a convex lens made of a glass of refractive index 1.5 is dipped in term. A medium of refractive index 1.65 and a medium of refractive index 1.33. Question is, will it behave as a converging lens or diverging lens? And second, how will its focal length change in two media? Okay, simple. Now we have Lensmaker formula. It was 1 upon f equal to mu L, that means medium of lens, upon mu M, refractive index of medium, minus 1 into 1 minus R1 minus 1 upon R2. Okay, now see the situation. This term 1 upon R1 and 1 upon R2 is decided by the construction, because these are the radius of curvature. So because of change in medium, this term will not change, it's for sure. Okay, see here, this is medium of lens and it is given 1.5, and this is mu m, medium in which lens is immersed or dipped. Okay, and this is f. F, we know that focal length, it is positive for convex lens. Okay, it is positive for convex lens, and that is called converging lens. Another name is converging lens. It will be positive and it will be negative for concave lens or diverging lens. Okay. Now see the term here. This term is fixed and here is mu L upon mu n. If this ratio mu L upon mu n is greater than 1, then this whole term will be positive, and so f will be positive and it will behave as a convex lens. If this ratio mu L upon mu m is less than 1, then this is less than 1 and this is 1, this term becomes negative. This term becomes negative, and so f becomes diverging lens or concave lens. Okay, now see the first case. In first case, it will be 1 upon, let us say it f1, mu L is 1.5 and refractive index of medium is 1.65. 1.65 minus 1 and 1 upon R1 minus 1 upon R2. See here, this ratio is less than 1. Because 1.5 is less than 1.65, so this term will be negative. So in this case, lens will be concave. Concave means diverging lens. Okay. In second case, the refractive index is 1.33. In this case, the medium of lens is 1.5 and refractive index of medium is 1.33 minus 1 and it is 1 upon R1 minus 1 upon R2. Now this ratio 1.5 upon 1.1 is greater than 1, so F2 will be positive, so lens will be convex or converging lens. Okay, simple question. In second part, how will its focal length change in two media? Okay, let's divide it. If I divide it, what will happen? It will be F2 upon F1 will be 1.5, 1.65 minus 1 upon 1.5 minus 1.33 minus 1. Now, after solving this, we will get this value as 4. So we can say that F2 will be 4 times F1. Okay. In second time, when refractive index becomes 1.33, then focal length becomes 4 times compared to first case. Okay. Another question on lens formula, lens maker formula. Okay. Here is the question. The radii of curvature of faces of a double convex lens are 10 centimeter and 15 centimeter. Okay. If focal length of lens is 12 centimeter, find the refractive index of material used. And we know that we have formula 1 upon F equal to mu L upon mu M minus 1 upon R1 minus 1 upon R2. Here second medium, that is medium, refractive index of medium is not mentioned. So by default we will take it as a air and mu M will be 1. Okay. Now given focal length is given, it is 12 centimeter. R1 is given, it is 10 centimeter. And lens is like this. If R1, this is R1, this is R2, it will be positive and it will be negative because of it is in the left side. So R2 will be minus of 15 centimeter. Okay. Now apply the formula. 1 upon F, that means 1 upon 12, and refractive index is not known to you, that means it will be mu L minus 1 and it will be 1 upon 10 and minus 1 upon 15. Okay, it becomes positive, it will be 1 upon 12 mu L minus 1 and it will be 30 and it is 3 plus 2. Okay, and it is 1 upon 12 mu L minus 1 equal to 5 upon 30, 5 6 and 6 2 ja. Okay, that is 1 upon 2 equal to mu L minus 1. So mu L will be 1 by 2 plus 1, it will be 3 by 2. Simple question and simple solution. Okay, thank you. Here is a next question. Question is a biconvex lens has a focal length 2 by 3 times the radius of curvature of either surface. Calculate the refractive index of lens. Very easy question. It is a biconvex lens. That means the radius of curvature will be same. That is magnitude of R1 must be equal to magnitude of R2 and let us say it R. Okay. Also given focal length is 2 by 3 times. That means F is 2 by 3 times R. That means R upon F must be 3 by 2. Okay. Now we have formula, lens maker formula, 1 upon F equal to mu L upon mu M minus 1 and 1 upon R minus 1 upon minus R. Okay, 1 upon F, and because medium is not mentioned here, by default we will take mu m as air, it will be mu l minus 1 and it becomes 2 upon r. Okay, now take r in left side, it will be r upon 2f equal to mu l minus 1. Okay, and r upon f equal to 3 by 2. That means 3 by 2 into 2 equal to mu l minus 1. So mu l will be equal to 3 by 4 plus 1. It will be 7 by 4. Simple question, simple solution. Thank you. Here is next question. Find the radius of curvature of convex surface of a plano-convex lens. What do you mean by plano-convex? That means one surface is plane and second surface is convex. Okay, whose focal length is 0.3 meter. That means f is given 0.3 meter. And as we know that the plane surface have radius of curvature infinite. Okay, and let it be r. It is unknown. Okay, and material of the lens is, that means mu l is 1.5. Just put the value. We have the lens formula 1 upon f equal to mu l mu m minus 1 upon r1 minus 1 upon r2. Okay. Focal length is given 0.3 meter. That means 1 upon 0.3. And mu l is 1.5. And because medium is not mentioned, by default we take it as a air. And 1 upon r. R is 1 upon infinity. And minus, it will be minus of r. Okay, let's remove the decimal. It is 10 by 3 and it will be 1.5 minus 1.5, that is 1 by 2, and 1 upon infinity 0, and it becomes 1 upon r. So 1 upon r will be 20 by 3, 10 by 3, and this is 1 by 2, 1 upon r. So it will be 20 by 1 upon r equal to 20 by 3. So r will be 3 by 20 meter. Okay, 3 by 20. A converging lens has focal length of 20 centimeter. Okay, that means f is given 20 centimeter and it is converging, that means convex lens in air. It is made of material of refractive index 1.6. That means mu l is given 1.6. If it is immersed in a liquid of refractive index 1.3, that means mu m is given 1.3. Calculate new focal length. Simple question. Let it is initially f when there is air. So mu l upon mu m minus 1 equal to 1 upon r1 minus 1 upon r2. When there is air, its focal length is 20 centimeter. Okay, we will put in last, let it f1. So f1 equal to mu l. Mu l is 1.6 minus 1 and it is 1 upon r1 minus 1 upon r2. Let it is equation number 1. Now when it is immersed, okay, when it is immersed. Okay, then let it be focal length f2. Then it becomes 1.6 upon 1.3 minus 1 and 1 upon r1 minus 1 upon r2. That's all. Be 1 upon f2 will be 1.6 minus 1.3 upon 1.3 into 1 upon r1 minus 1 upon r2. Okay, it comes as 0.3 upon 1.3 into 1 upon r1 minus 1 upon r2, and it will be 1 upon f2. Let's divide. Okay, let's divide both equations 1 and say it as a 2. 1 upon 2. So it becomes f2 upon f1, f2 upon f1, and equation 1 is here 1.6 minus 1, it will be 0.6. Okay, and here is 1 upon r1 minus 1 upon r2, here is also 1 upon r1, 1 upon r2, it will be cancelled. So here is 0.3 into, it becomes 1.3. We can remove the decimal, it will be 2. So f2 will be, it is 2.6 times f1, and f1 is 20 centimeter. It is 20 centimeter and it is 2.6. So it is 20. So 40 and 12, it becomes 52 centimeter. So the new focal length will be 52 centimeter. Okay, that's simple question.